A review of atoms and elements, part 1. Today we're going to be looking at the law of conservation of mass, the law of definite proportions, the law of multiple proportions, Dalton's atomic theory, and then finally, nuclear theory of the atom. So let's talk briefly about the law of conservation of mass. The law of conservation of mass was proposed in 1789 by Antoine Lavoisier, which stated, in a chemical reaction, matter is neither created or destroyed. Over the course of a reaction, the total mass of the substances involved will remain the same, which means the mass of your products will equal the mass of your reactants. Let's look at an example of this. A combustion reaction occurs between 12 grams of oxygen and 1.5 grams of hydrogen. What is the mass of water vapor produced? So here I have my balanced equation showing oxygen reacting with hydrogen to produce water vapor. We can represent this by stating 12 grams of oxygen plus 1.5 grams of hydrogen. If we add those two masses of reactants together, we get 13.5 grams of water vapor. And really, this is what the law of conservation is getting at. I give you masses of the reactants. They should, in a perfect world, all be accounted for in the mass of the products. Let's look at another example. The gas tank of a car can hold a maximum capacity of 21 kilograms of gas. As the gas combusts, 84 grams of oxygen was consumed. Carbon dioxide and water were produced as a result of the reaction. Determine the mass of the products produced. So when we look at this, I'm going to represent my gas as octane right here. So we have 21 kilograms of octane, plus we have 84 kilograms of oxygen that was also involved in this combustion reaction. So when we add these two together, we get the mass of the total products of carbon dioxide and water, which in this case is 105 kilograms of products. Don't overthink these types of problems. They give you the mass of one of the reactants, they give you the mass of the other reactant. All they want is a total mass produced. Now let's talk about the law of definite proportions, also known as the law of constant composition. All samples of a given compound, regardless of their source or how they were prepared, have the same proportions of their constituent elements. Let's look at an example of this. 2 samples of carbon monoxide are decomposed to form carbon and oxygen gas, and here is my chemical equation representing that. I have 2 samples of carbon monoxide from different sources. I need to see that the ratio between the carbon and the oxygen in each one of these samples is the same, no matter that the beginning masses are different. So the way that I'm going to do this is I'm going to say, well, I have 12.9 grams of carbon and I have 17.2 grams of oxygen, and I want to see the ratio of basically one carbon to how many oxygens. So I'm going to divide this carbon by itself, so 12.9, and divide this sample of oxygen by my mass of carbon, so 12.9. And when I do this, 12.9 divided by 12.9 is 1. And when I divide 17.2 by 12.9, I get 1.33. So the ratio here is 1 gram of carbon per 1.33 grams of oxygen. So that's for one sample. Let's look at sample 2. We have 7.88 grams of carbon and 10.5 grams of oxygen. So I'm going to divide the carbon by itself because I want the carbon to be representing basically 1 gram. So 7.88 grams of carbon. And then I'm going to divide the mass of the oxygen by the mass of the carbon. So 7.88 grams of carbon. So when I divide 7.88 by 7.88, obviously I'm going to get 1. And then I do 10.5 divided by 7.88, and oh look, I get 1.33. So the ratio between carbon and oxygen in each one of these situations is 1 to 1.33, no matter what the source is. So this is an example of the law of definite proportions. Now, the law of multiple proportions is when two elements form different compounds. The masses of element B that combine with 1 gram of element A can be expressed as a ratio of small whole numbers. Let's look at an example of this. Hydrogen and oxygen form both water and hydrogen peroxide. So we've got water, which we know is H2O, and a little reminder, hydrogen peroxide is H2O2. The decomposition of a sample of water forms 1.25 grams of hydrogen to every 1 gram of oxygen. The decomposition of a sample of hydrogen peroxide forms 0.250 grams of hydrogen to every 1 gram of oxygen. Show that these results are consistent with the laws of multiple proportion. So let's break this down again. We have water, and in water we have 0.125 grams of hydrogen to every 1 gram of oxygen. And then for hydrogen peroxide, H2O2, we're going to have 0.250 grams of hydrogen to every 1 gram of oxygen. So what they want to see is that we know that each of these is going to differ by an oxygen. And because they're differing by an oxygen, we want to see the relationship between these two. So what we're going to do is take the larger number of hydrogen, so 0.250 grams of hydrogen, and divide it by the mass of hydrogen in water, which is 0.125 grams of hydrogen. And when we divide these two, we get a whole number of 2. So we can see by looking at these masses and looking at this ratio that the difference will show as a whole number. Let's look at another example. Two different compounds are formed by the elements carbon and oxygen. The first compound contains 42.9% by mass carbon and 57.1% by mass oxygen. The second compound contains 27.3% by mass carbon and 72.7% mass by oxygen. Show that the data are consistent with the law of multiple proportions. I'm going to basically assume that 100% is 100 grams. So I have sample number 1 right here, and I'm going to have 42.9 grams, because I'm just going to assume that this is out of 100 grams of carbon, and 57.1 grams of oxygen. And like I did before, I'm going to look at the ratio of carbon to oxygen. So I'm going to divide this by itself, 42.9 grams of carbon, and I'm going to divide this one by 42.9 grams of carbon. And when I do this, the ratio I get here is 1 to 1.33. And this should look very familiar to a previous example that we did dealing with carbon monoxide. So this ratio of 1 to 1.33 says to us, hey, we're dealing with carbon monoxide. But let's look at the second compound. The second compound here has 27.3% by mass carbon, so again I'm just going to call that grams of carbon, and 72.7% by mass oxygen, I'm just going to call that grams of oxygen. And like I did over here, I'm going to divide this by itself, 27.3 grams of carbon, divide this large number, 27.3 grams of carbon. This is going to turn out to be 1, and this is going to be 2.66. So now I have these ratios. What I want to do is I want to look at this number right here, the 1.33 and the 2.66, because they are saying that these are two different compounds. They both have carbon and oxygen. So if I divide 2.66 by 1.33, I should find a whole number ratio. And when I do that, I find that that is 2. So most likely this sample right here is carbon dioxide. And we can see that this is a 1-to-1 ratio, this is a 1-to-2 ratio, and this basically reinforces the law of multiple proportions. The 4 postulates of Dalton's atomic theory. Each element is composed of tiny, indestructible particles called atoms. All atoms of a given element have the same mass and other properties that distinguish them from the atoms of other elements. Atoms combine in simple whole number ratios to form compounds, and atoms of one element cannot change into atoms of another element. Now remember, these were the original postulates of Dalton's atomic theory. We know that they change over time, but this is what he originally proposed. Nuclear theory of the atom. Most of the atom's mass and all of its positive charge are contained in a small core called the nucleus. Most of the volume of the atom is empty space. And finally, the atom is electrically neutral, as the number of electrons outside the nucleus will equal the number of positively charged particles in the nucleus. Now remember, Rutherford did not know about protons and neutrons, but he knew that the nucleus was positively charged and that there were electrons on the outside, and between the two, they would make the atom electrically neutral. Content you're responsible to know from this chapter. The general composition of the atom. Your subatomic particles, protons, neutrons, electrons, where they're located, and their charge. The difference between an atom and an ion. You need to know the concepts of atomic number, mass number, and what is an isotope. And finally, the periodic law and the basics of the periodic table, which we'll go over in more detail in the future, but this is all content that you should remember from Regents Chemistry. So what did you learn? We revisited the concept of the law of conservation of mass. We talked about the law of definite proportions. We talked about the law of multiple proportions. We looked at Dalton's atomic theory. And finally, we talked very briefly about the nuclear theory of the atom. Need more help? Feel free to contact me. Have a great day.